Welcome to Module 3, Lesson 7 of our CASP Plus course. This lesson in Security Engineering and Cryptography covers the following topics, such as key rotation, mismatched keys, improper key handling, embedded keys, exposed private keys, crypto shredding, cryptographic obfuscation, and compromised keys. Troubleshooting issues with cryptographic implementations. We can anticipate encountering issues with compatibility, configuration, and operational issues that disrupt communication or lead to insecure execution in an enterprise supporting PKI implementation. It is critical to identify potential hotspots for these issues and look for ways to address them through efficient policies and procedures. The first concept is key rotation. To maintain data confidentiality, it is crucial to understand the advantages of key rotation. Depending on the organization's policies or as required by regulatory compliance, keys may be rotated automatically or manually. A key must be immediately revoked if it has been compromised. Depending on how many records or transactions have been encrypted, the PCI DSS mandates that keys be changed periodically. An organization should also take other factors into account, such as staff turnover, the security of the encryption keys in the use, and the importance of the data. On appropriate key rotation timelines, the National Institute of Science and Technology, or NIST, provides the advice for this one. So NIST Special Publication 800-57, Part 1, Revision 5, is available on this specific URL here. Next is mismatched keys. Now, to properly consider key rotation, all dependencies must be recorded. A key mismatch may happen, for instance, if the public key is hard-coded into software of hardware devices and a key is rotated on a crucial independent module. To prevent this, documented policies and procedures should be used. Next is improper key handling. Strong policies and procedures must be in place for the handling of encryption keys. The function of key generation and assignment ought to be given to particular administrators. Separation of duties should be taken into consideration when there is a chance of fraud. Now, limiting the amount of time a private or secret key is in plaintext form, limiting who can view plaintext keys, and storing keys in secure containers are just a few of the recommendations made by NIST to increase the security of key handling. Let's talk about embedded keys. So, when it's necessary to ship computers or other hardware with default secure configurations, vendor may choose to use embedded keys. Windows operating systems set up for a secure boot could serve as an illustration. The Unified Extensible Firmware Interface, or UEFI, firmware includes the Microsoft public key. This enables secure booting from the very beginning of use. Now, due to the computer's intended use, the embedded key may occasionally need to be updated or modified. The embedded key, which is the public key for the Linux distribution, needs to be changed if we want to install Linux on the system and take advantage of a secure boot. Exposed private keys. Private keys must be kept safe because an attacker can use them to decrypt sensitive information. A secure option for storing private keys is a crypto module. Private key security is handled by a specialized device called a hardware security module, or HSM. When sensitive keys are needed for secure transactions, an HSM can be a secured appliance in the data center. Private keys can be kept in escrow where there is a business need or compliance requirement. Next is what we call as crypto shredding. Cryptographic shredding may be a good option when it's necessary to make sensitive or confidential data unreadable. This would entail using specific encryption keys to encrypt the data while it is at rest. The sensitive data could then be destroyed by deleting the encryption key that was used. When a storage device cannot be physically accessed, such as when data is stored by a third-party cloud provider, this may be helpful. Access to the data won't be possible after the key has been destroyed. This technique is used to make the data unrecoverable, much like physically shredding a hard drive. On Apple iPhones, a method known as cryptoshredding is employed. If the PIN number is entered incorrectly 10 times, the Advanced Encryption Standard or AES encryption key is deleted, rendering the device storage inaccessible. Next is cryptographic obfuscation. Modern encryption ciphers use intricate mathematical techniques to safeguard the cipher's keys. The purpose of multiple levels of confusion and diffusion is to make cryptojob analysts extremely challenging. Regulatory organizations frequently demand new security protocols, as well as the use of longer encryption keys and more complicated cipher block modes in existing ciphers. In the event that the plaintext needs to be accessed without the encryption key, it is difficult to reverse a cipher given these conditions. And the last concept is compromised keys. So once a key has been compromised, it needs to be removed from use and added to the CRL. This must be completed as soon as possible as well. This may need to be done right away or at the very least within a few hours, depending on the value of the data and the potential for exposure. Private keys that have been stolen are an example of a compromised key. Alright, that's the end of the lesson. In this lesson, we spoke about key rotation, mismatched keys, improper key handling, embedded keys, exposed private keys, crypto shredding, cryptographic obfuscation, and compromised keys. That's the end of the lesson and the end of the module. Thank you very much for watching the video.